Good morning, friends. I'm Harshada. I'm going to explain the topic called concurrency control in distributed database. What is meant by concurrency control? Concurrency control is a technique that ensures multiple transactions can be executed simultaneously, maintaining the ACID properties of transaction and serializability in the schedules. Types of concurrency controls, that is block-based protocols and timestamp-based protocol. Block-based protocol again divided in two types, two-phase locking protocol and the graph-based protocol. Also, timestamp-based protocol divided in two types, that is timestamp ordering protocol and the Thomas Wright rule. Let's see lock-based protocol briefly. A lock is a mechanism to control the concurrent access to a data item. Data items can be locked in two modes, that is exclusive mode and the shared mode. In exclusive mode, data items can be read or write. Both operations can be performed on data items. It is requested using the lockx instruction. In shared mode, data items only read means only read operation can be performed on data items. It is requested using lockx instruction. Lock requests are made to concurrency control manager and transaction can be proceed only after that request is granted. First type is two-phase locking protocol. In this protocol, which ensures that conflict serializability schedules. In this, mainly two phases are present, that is growing phase and shrinking phase. In growing phase, transaction may obtain the locks, but it cannot be released. It may not release the lock. In shrinking phase, transaction may release lock, but it may not obtain the locks. The protocol assures serializability. It can be proved that the transaction can be serialized in the order of their lock points. Lock points are the points where the last transaction can be happen. Types of two-phase locking protocol. For mainly three types are present, that is strict two-phase locking, rigorous two-phase locking and conservative two-phase locking. Firstly, we see strict two-phase locking. In strict two-phase locking, all the exclusive locks that are to be transacted are executed before the commit operation can be performed by the transaction. In rigorous two-phase lock, with exclusive lock, shared lock are also to be executed before the transaction commits. In conservative two-phase lock, in this it requires the transaction to obtain all the lock before it start and release all the lock before it commit. After it commit. Second type is graph-based protocol. Graph-based protocols are alternative to two-phase locking protocol. It imposes the partial ordering on the data items. If DI tends to DJ, then any transaction accessing both DI and DJ must access DI before the accessing DJ. It implies that set D may not be viewed as a directed acyclic graph called database graph. A tree protocol is a simple kind of graph-based protocol. In tree protocol, only the exclusive locks are allowed. The first lock by the TI may be on any data item. In this, if parent is locked, then only the children can be locked. But it can be unlocked on its data item can be unlocked in any time. Then, in tree protocol, it ensures that conflict serializability as well as it is free from the deadlock. Unlocking may occur earlier in tree protocol than the two-phase protocol. It has shorter waiting time, the protocols is deadlock free, and abort transaction can still lead cascading rollbacks. In tree protocol, a transaction may have locked data item that it does not access. Schedules not possible under two-phase locking protocol, but it is possible under tree protocol. Second type is timestamp ordering protocol. In timestamp ordering protocol, it ensures that any conflicting read and write operations are executed in timestamp order. If not, such an operation is rejected and the transaction will be rolled back. Then that rollback transaction again restarted with new timestamp. Each transaction is given unique fixed timestamp, that is TS TI. If any transaction Tj enters after Ti, then relation between the T timestamps will be Ti is less than Tj, which means resulting schedule must be equivalent to a serializable schedule. This is the diagram with example. Then Thomas Wright rule. It is the modified version of timestamp ordering protocol, which means in this only the write operations may be ignored under certain circumstances. If Ti items to write data items on queue, then it can be easily rolled. It rather than rollbacking, it is ignored by the Thomas Wright rule. Otherwise, it is same as the timestamp ordering protocol. Thomas Wright rule allows greater potential concurrency. Unlike previous protocol, it allows some view serializability schedule that are not conflict serializable. Thank you.